For this problem, we're going to be talking about continuity. So we're supposed to find functions, two functions, f and g, such that each function is continuous at 0, but f of g of x is not continuous at 0. So with the first, for it to be continuous, the limit of f of x is x approaches c has to be equal to f c. Our c in this case is going to be 0. So for the first problems they give us, it's f of x equals 2x cubed minus 3x, and g of x would equal 5x squared. So we have to take the limit of each of these and then see if they're equal to when you plug in 0 into the function. So the limit is x approaches 0 of 2x cubed minus 3x. That would equal 0. And f of 0 would equal 0 as well. So that is continuous at 0. G of x, we're going to do the same thing. X approaches 0 of 5 squared. Once you plug in 0, this will equal 0. And then g of 0 would also equal 0. Then we're going to have to check the composite function, which is f of g of x. So we substitute g for all the x's in here. But we can already tell when you substitute that, it won't make much of a difference, just make it more exponents. So it shouldn't change if it's continuous or not at 0. So we know this is still going to be continuous at 0. Okay, for the next problems, we have f of x equals square root of x plus 1, and g of x equal 1 over x plus 1. So we're first going to check the limit as x approaches 0 of x plus 1. That would equal 1. And then f of 0 would also equal 1. So they are equal, so it is continuous. We do the same thing for g of x, which would equal 1, and g of 0 would equal 1 over 0 plus 1. So again, they're both continuous at x equals 0. So now we're going to have to check if f of g of x is continuous at x equals 0. So we're going to substitute all g of x as x. So then f of g of x would equal 1 over x plus 1 plus 1. And so we're going to check the limit of that and check if f of 0 equals the limit. So now we have to check the limit of this as x approaches 0 of 1 over x plus 1 plus 1. And that would equal 1 over 0 plus 1, which should equal the square root of 2. So now let's check f of g of 0. And that would equal 0 plus 1, which again equals the square root of 2. So therefore this is continuous, which is not what we're looking for. We're trying to find what is not continuous. So next we're going to check the last set, second to last set, sorry. And we have for this one, f of x equals 1 over x minus 1, and g of x would equal x plus 1. So to check the limit as x approaches 0, 1 over x minus 1, this will equal negative 1. And f of 0, 1 over 0 minus 1 would again equal -1. This is continuous. The limit of x approaches 0 of x plus 1 would equal 1, and then g of 0 would equal 0 plus 1, which equals 1. It is continuous. Now let's check f of g of x, which is the composite function. So then we're going to replace all the g of x with x. So f of g of x would equal 1 over x plus 1 minus 1, which simplifies to 1 over x. And we know with 1 over x, x cannot equal 0. Therefore, it can't be continuous at 0. And that means this has been the set of problems we've been looking for, in which both are continuous, but when you do f of g of x, 0 will not be continuous. And we're asked to explain why these examples do not contradict the continuity of composite functions and point theorem. It does not contradict the composite of continuous function theorem because f of g is continuous at every point of its domain. Also, for f of g of x to be continuous at 0, f must be continuous at g of 0, but f does not need to be continuous at 0.